Hi, my name is Stuart Marks, and I will be talking about the Java Collections Framework today. The title of this talk is Collections Refueled. I'm a consulting member of staff at Oracle. I work on the JDK and at OpenJDK, and I work on a whole bunch of different things, including the collection framework. So what I will be talking about today is some enhancements we've made in the collections framework in JDK 9 and later releases. I know there are a lot of people who are working on JDK 8 and who are looking to upgrade to a later JDK release, such as JDK 11. And so these are some enhancements that are waiting for you when you arrive at a later JDK. So I'll start off with an overview of the APIs that we've added, and I'll have some examples sprinkled in there. And then I will do some deep dives into various technical issues with the use of those APIs, such as how to create a map with an arbitrary number of entries, idempotent copying, a few words about unmodifiability. These collections are all unmodifiable. Some issues with iteration order and randomized iteration order, handling of duplicates, and the space efficiency of the new collections. So with that, let's dive right into some API examples. Okay, let's say you have some code written for Java 8, and you wanted to create an unmodifiable list of strings. And so one way to do that is to start off, and I'm going to read the code from inside out, take those strings and call arrays.asList on them. And so now we have a list of strings A, B, and C, and then wrap that in an unmodifiable list wrapper. And finally, assign that to some variable like string list. And so that's not too bad. It is a fair chunk of code. But in Java 9 and later, there's a new API called list.of, and you can simply put those three strings right in there, list.of A, B, C, and assign that directly to string list. And so that's pretty nice. That makes things nice and concise compared to Java 8 and earlier. Now let's take a look at doing something fairly similar, except we want to create a set of strings instead of a list of strings. So we start off in a similar way on Java 8, create a list using arrays.asList. And that's a little odd because then what we do is we turn around and pass that directly to the hash set constructor. And once we've gotten a hash set, we wrap that in an unmodifiable set and then assign that to our string set variable. But again, in Java 9, we have a much nicer API to do that. A new set.of API lets us put those strings directly into the set.of call and assign that to our string set variable. So that gets quite a bit nicer than in Java 8 and earlier. Now let's create a map with a few entries. Now this one is a little bit more difficult. In Java 8 and earlier, what we'd generally have to do is create an empty hash map instance and store it in a variable somewhere. Then we'd have to call put repeatedly on our key and value that we want to initialize into that hash map. And then finally, when we're done with that, we wrap an unmodifiable wrapper around the map and then assign that to the variable we want to. And so that's quite a lot. In Java 9, we have a new map.of API where we can put those key value pairs directly as arguments to map.of. So map.of A1, B2, C3 creates a map that has exactly what we want in it and assigns it. Then we can assign that to the string map variable. One of the things that made the Java 8 style API particularly difficult was it was impossible to initialize a field in one line. What you had to do is put these sequence of statements into a constructor or static initializer. And so that meant that the code that actually initialized the field was far away from where the field was. And in Java 9 and later, if you wanted to initialize a field, you can do that directly in the field initializer using the map.of API. Okay, now let's take an overview of the APIs. I just talked about the various of methods. There's list.of, set.of, and map.of. these are static factory methods on the list, set, and map interfaces. And so in each case, what we have is a set of static factory methods that take different numbers of fixed arguments. So there's list.of that takes 0 arguments, that obviously creates an empty list. List.of taking 1 argument, that creates a list with 1 element. List.of with 2 arguments, and so on up to 10 elements. And finally, if you need more than 10 elements, we have a varargs style API, list.of elements ... and that can take an arbitrary number of elements, and it will populate a list with those elements and return it. It's the same with set.of. There's static factory methods that take 0 arguments all the way up to 10 arguments, plus a varargs overload that takes an arbitrary number of elements. Now map.of is slightly different. There's a map.of that takes 0 arguments, that initializes an empty map. But now, if we want to have one mapping in that map, we pass a key and a value. So we have a key value pair as arguments. And we can pass 2 key value pairs, map.of k1, v1, k2, and v2, and all the way up to 10 key value pairs. So that would be a really long argument list, but you could do it. You could create a map with 10 key value pairs and initialize it with map.of. Now notice there's no varargs overload here. And so if we want to create a map with an arbitrary number of values, we have to do something different. So there's a little bit of complication here. Before we create a map with an arbitrary number of values, what we have to do is learn how to create map entries conveniently. So map.entry is an interface that's been around for a long time in the JDK, but it's been rather inconvenient to create instances of it. A map.entry is simply a key value pair. And so what we've done is we've added a static factory method that creates a map entry, and it's called map.entry, and it takes a key and a value. And so that's fairly simple, and it gets even simpler if you statically import the map.entry method. Now that we have an easy way to create a map entry, we can now use the new map.ofentries method to create a map with an arbitrary number of entries. And so what map.ofentries does is it takes a varargs parameter of map entry objects. And so what we can do is we can pass it as many map entry objects as we want, each of which has been created with the map.entry method. So here we have map.ofentries and an entry of k1 and v1, followed by an entry of k2 and v2, and so forth. So this is a little difficult to manage, or a little difficult to imagine. And so on this slide, I have an example of how you would use that in practice. If you want to initialize a map with a large number of entries, about 13 in this case, you would probably want to put each key value pair on its own line. And so we wrap each key value pair in a call to the entry method, and we have a sequence of those, 1 per line, and then we pass that entire list of map entries to the map.ofentries method. And that will create the map with all of these entries in it, and then return that, and that's what we assign to the tokens here. So you can see in the example, we can easily edit the number of entries. We can add and remove them quite easily because there's 1 entry per line. And each call to the map.entry method returns 1 map entry, which again is a key value pair, and those in turn get passed to the map.ofentries method, which creates the map. So it's very simple to create a map with an arbitrary number of entries. It's just that you can't use map.of. You have to use map.ofentries instead. Okay, there are a few more methods that we should take a look at here. There's a family of methods called copyOf on the list, set, and map interface. And so list.copyOf takes a collection and takes those elements from that collection and makes a list out of it. Set.copyOf takes a collection and makes a set out of it. And map.copyOf takes another map. There are also ways to create these unmodifiable maps from streams. And so if you have a stream pipeline, if the terminal operation is a collect operation, you can pass the elements of the stream to a collector. And so we've added a few new collector implementations that reside in the collectors class. So there's two unmodifiable list, two unmodifiable set, and two overloads of two unmodifiable map. And what those do is the two unmodifiable list and set collectors fairly straightforwardly take the contents of the stream and load them into a new list or a new set. And then the two unmodifiable map overloads take each stream element, but then run a function on that element to produce the key, and then they run a different function on it to produce the value. And so that's what keyfunc and valuefunc do. And there's a different overload that takes a merge function. If there are duplicate keys, the merge function is called on the old and new values, and its responsibility is to produce a single merged value that is derived from both the old and the new values. I'll have an example of that later. So I'd like to introduce this idea of idempotent copying, and that's what the copyOf methods do. But first, let's introduce an example here. Suppose we have a simple piece of code which is maintaining an employee database, and that has a field in it which is a list of employees. And now we have a setter method on this employee database class that sets the employees to and it passes in a list of employees. Okay, so how would we do this? So at line 1, you could consider taking the parameter that was passed in and assigning it directly to the employees field. We probably don't want to do this because whoever called this method might still have a reference to that list, and if they later go on and modify that list, then that would also have a side effect of modifying the list that's stored in the employee database. So what we want to do is we want to make a copy of whatever was passed to us. So in Java 8, you can see how you might do that in line 2 here. We might create a new array list containing all the elements of the new employees. And then just to make sure that we don't accidentally modify it in this class, we wrap it in an unmodifiable wrapper and then assign it to the field. And so that works. That's a fine thing to do. But there's an easier way. In recent versions of the JDK, we can take the new list of employees and simply call list.copyOf and then assign the result to the employees field. Now let's take a look at what happens if somebody outside might call this setEmployees method, and if they pass suppose they pass a list of employees using this nice new list.of method. Suppose they pass a list of Alexis, Brett, Chris, and Dana. And so that creates a list. And then when they come into this method that's implemented using line 3, we call list.copyOf. And so that makes another copy of the list and then assigns it to the employees field. Well, isn't that wasteful? Well, in fact, it doesn't actually make an extra copy. So what list.copyOf does is its responsibility is to produce an unmodifiable list containing the same elements as the list passed in. Well, if the list is already unmodifiable, it simply returns its argument. But if the list it's passed is not unmodifiable, then it will make a copy. So in this case, we take list.of Alexis, Brett, Chris, and Dana, and that's an unmodifiable list. We pass that to setEmployees, and the setEmployees method calls list.copyOf, which says, that list is already unmodifiable. We don't need to make another copy. And therefore, we can safely return the argument and then that's assigned to the employees field. So list.copyof is smart. It only makes a copy if it needs to. And we say it's an idempotent copy because if we attempt to copy it more times than are necessary, it only makes one copy. All right, I've hinted around unmodifiability a little bit, and I wanted to talk about that in a little more detail. So all of the collections that are produced by these new APIs are unmodifiable. And by that we mean if you take one of these lists and call add, set, or remove on it, or call any other methods that might happen to try to modify the collection, they will throw unsupported operation exception. So what good is this? I mean, isn't the idea of a collection that you want to add things and remove things to it? Well, you do that with many collections, but in fact, it is actually quite common to initialize a collection to a known set of values and guarantee that that set of values never changes. This happens quite often at initialization. So for instance, if you recall my example of map.of entries from a few slides back, that initialized a table of symbol types or token types. And if you're writing a parser or a compiler or something like that, your language might define the set of token types, and that never changes throughout the run of the program. So it makes sense for you to have a data structure that is initialized and never changed. And so that's the use case for an unmodifiable collection. There's another use case, which is it makes it easier to reason about your program if you can arrange for your data structures never to be modified. And so if you have a data structure that is modified, then you have to start worrying about what order operations occur in, if multiple operations need to be done atomically. If in the case of concurrency, you have to think about locking, you have to think about potentially exposing invalid states if something gets in between multiple operations. If you have a data structure that is created once and is never modified, then that is a big step towards it being thread safe. And so you can pass that around and have multiple threads read from that data structure without worrying about any of the thread safety issues that come along with mutation. So that's the benefits of unmodifiable collections. Now, you might also be saying, well, why aren't we talking about immutability? So we are calling these collections unmodifiable collections. We're not calling them immutable collections. And the reason is it is still possible to put a modifiable object into one of these collections. And so if you were to do so, then the whole thing is modifiable, and therefore it's not immutable. So we're not calling the collections immutable because there's no magic here. There's nothing that confers immutability on things that get put into these collections or anything like that. Now, you can make an immutable data structure out of these collections if you make sure that everything you put into these collections is itself immutable. So if it's immutable all the way down, then you can wrap some immutable things in an unmodifiable collection, and the whole collection is immutable. But the fact that you can put a modifiable object inside of one of these collections is the reason we're not calling them immutable collections. So really, they're unmodifiable collections. You cannot modify the collection, but you still might be able to modify things that are inside of the collection. Okay, a few words about iteration order. So most sets and maps, the most common sets and maps at least, are based on hashing. And so hash set and hash map are the data structures that are most commonly used in the JDK. And you can iterate over them. So you can iterate over the elements of a hash set, or you can iterate over the entries of a hash map. And the order in which these elements or mappings are iterated is unspecified. Now, it happens that the hashing algorithms and these data structures don't change very often. So even though the order is unspecified, you will probably get consistent hash iteration order for a very long period of time, even if you upgrade JDKs. this this iteration order can be stable for years at a time. And the problem with that is that you can write some code and that code can be working perfectly fine, but you might accidentally write some code that depends on this particular iteration order. And there are times when we do have to rearrange the data structures of hash map or hash set and change the iteration order. We try not to do that from one release to the next, but sometimes it does happen. And when that does happen, it tends to break this code that has accidentally created order dependencies on iteration, on the order of iteration of methods in hash map and hash set. So we've done something slightly different with the new map and set implementations. Here we deliberately randomize the iteration order, so it changes from one run of the JVM to the next. And our goal is to prevent code from inadvertently creating dependencies on this iteration order. And so that, I think, has served its purpose. Since applications that use these new collections are presented with a different iteration order every time, they're forced to make sure that they haven't accidentally depended on a particular iteration order. And one thing that allows us to do is to change the internal organization of these data structures at will, because we don't have to care about preserving a particular iteration order, because it is randomized after all. And we have taken advantage of that in JDK 9 and 10 and later releases. We have changed things that would have affected the iteration order, and we've been able to provide more optimization and better space efficiency because of that. Now, I do want to point out that this applies only to the new set and map implementations. The randomized iteration order occurs only in the new set and map implementations. Hash set and hash map are unchanged. We haven't randomized the iteration order of those. However, I will repeat this morning, they may change in the future. So there may be a problem if we change the iteration order of hash map and hash set. We haven't yet, and we don't intend to, but we might. It could happen, and that might break some code. So if you are concerned about iteration order dependencies that you might have, I recommend using linked hash set and linked hash map for your collections, because those do have defined and predictable iteration order. Okay, now I wanted to switch over to a demo to show you what's going on there. All right, so this is a shell window, and I'm going to type JShell. And so if you're upgrading from JDK 8, this is something new. JShell is a new tool that we introduced in I think it was JDK 10. And what that allows us to do is type Java expressions interactively. So let's see what happens when we create a new hash set with several items in it. Oh. And you can tell that's interactive because I didn't intend to make that error. There we go. So we've created a hash set with 3 integers in it, 1, 4, and 7. And just because of the way hashing works, they happen to come out in order, which is a little bit of a coincidence, but that's the way hash set works. So now what happens if we create a set of the same integers? Well, that's interesting. They came out in the same order. All right, now I'm going to exit JShell. And so JShell runs a JVM, so I'm going to restart it, and that's going to be another instance of JShell. And so I'm going to create a hash set with the same integers, 1, 4, and 7. And what do you know? They come out in the same order. But now I created a set.of 1, 4, and 7, and they come out in a different order. And so set.of is the new API. And so in general, the order of elements that you iterate will change from one run to the next. And so if you write some code that accidentally depends on 1 coming before 7, then if you run if you write a test that does this and then you run this again, set.of might give you a different order that will cause that test to break. So we hope that will tend to flush out any order dependency errors very early on in your development cycle. Okay, let me switch back to the slides now. Okay, so there's another interesting characteristic here, which is that the set and maps, if you are explicitly listing the elements or mappings, they disallow duplicates. And so the idea is that these APIs are kind of like collection literals, where if you're writing out a collection literal, if you want to add duplicate things to a set, that's probably an error, and maybe you meant to do something different. And sometimes people say, well, you should just deduplicate those. You should just omit the duplicate entries. And so the problem is you might end up with a missing entry, and it's not obvious why. And so there are also some collectors that do that. So the collectors.toMap and toUnmodifiableMap collectors will also throw an exception if they encounter duplicates. And so if we want to do deduplication, if you want to compress out duplicates, then you should use different APIs. You should use set.copyOf, or the toUnmodifiable set collector, or the 3-argument toUnmodifiableMap collector, which allows you to explicitly handle duplicate elements using a merge function. So let me show you an example here of why I think this is important. So let's go back to our symbol table. We have map.of entries, and we have a bunch of token types here. And it turns out this code has a bug in it. And if we were to simply compress out duplicates, then this might be this might cause some very strange behavior at runtime. So there are 13 entries listed here, but if we compressed out duplicates, the map would only end up with 12 entries. And so this might be very hard to spot. And so just to make it easier, I've highlighted the duplicate ones. You can see there's a typo here. Somebody put a semicolon instead of a colon. And so that's an error. And so if you run this, you'll get an error at runtime. So here's a quick example of how you can use the toUnmodifiableMap collector to gather data together and handle duplicates explicitly. Suppose we have a player and a record data structure that consists of the player and the number of points scored on a particular play. If we have a list of those, we can stream them into the toUnmodifiableMap collector. And what we can do is, one player might have had multiple scoring plays. And so this third function here is integer : sum. And that will sum the scores by the same player and then store the sum into the resulting map. Finally, a couple words on space efficiency. The new data structures are organized in a different way. We do not support explicit constructors on explicit class names. Instead, the actual implementations are hidden behind static factory methods. This allows us to have different implementations for different sizes. And so we have singleton objects if there are 0 elements. We have field-based implementations for a very small number of elements. And we use array-based implementations for larger numbers of elements. And a quick comparison, if you have a hash set, if you have in an unmodifiable wrapper containing 2 strings, that takes us a total of 6 objects and 152 bytes. And that's the overhead only. That's not counting the strings themselves. Whereas if you put those same 2 strings into set.of, that only takes 1 object and consumes 20 bytes. So the new collection implementations are much smaller than the existing ones. Okay, let me wind up here. So we've added some new collections to JDK 9 and 10, and so you'll definitely get those if you upgrade to JDK 11. They're definitely useful for initializing constant data in a static initializer or in a constructor, or they're also a convenient way to do defensive copying or to pass collections with known arguments, known elements as an argument to a method call. So start using them in your code today. All right, coming up next, we have a couple hands-on labs using OCI to build a Java application and modernizing WebLogic Server on OCI. For information and instructions on how to join, please visit this website, developer.oracle.com/devlivejava.